Hello, this is I Math It with Samuel, okay? And in this lesson, I am going to be showing you how to solve this exponential equation using the Lambert W function. And that is the reason why this problem is seemingly impossible, because the elementary method will not work. So let us divide both sides by 2 to the x, okay? So when we divide both sides by 2 to the s, I can rewrite the power 2 to the s there as 1 divided by 2 to the s, right? And take the product with 2s minus 4 equals 2 to the s divided by 2 to the s, which is 1. So this is the same as 2x minus 4. 1 divided by 2 to the s is 2 raised to the power negative x. So, and you probably know if you have something like a raised to the power negative something like m, so it is going to be equal to 1 divided by a raised to the power positive m, right? So let us go on with this, and this will be equal. This is equal to 1. So what we are trying to do here, applying this method, is we want to express the power of 2 in a form that will be similar to what the function you have before that 2, okay? So let us divide both sides by 2 to get the x by itself. It will be easier for us to deal with this that way. So we have 2s minus 4 and multiplied by 2 to the negative s divided by 2 equals 1 divided by 2. So when we carry out the operation, we have x minus 2, because 2s divided by 2 cancel out 2, and 4 divided by 2 is 2. So now we have s minus 2 here, and we have negative s there. So I want to re-express this in form that the power there will be the same as what we have in the bracket there. So let me introduce negative to both sides first, because we have negative s up there, so that the x we have here will be negative. So let me put x outside the bracket here, and I'm going to have to put it on the other side. So we have negative x and plus 2. Right, that's what we have now, and 2 raised to the power negative s equals negative 1 divided by 2. Now we also have plus 2 there. How do we get plus 2 up there? So if we multiply both sides by 2 raised to the power 2, you will notice that the law of indices will allow us to add up the power for 2, right? And that is why we have negative x plus 2 and multiplied by e to the negative s, and we're going to multiply that by 2 raised to the power 2, and all of that is equal to 1 divided by 2 and multiplied by 2 raised to the power 2. 2 raised to the power 2 is 4, so let me put down 4 there. Okay, next, this is going to be negative x plus 2 and 2 raised to the power negative x and plus 2. So at this point, you notice that the power there is the same as what we have there. So now we're going to utilize an interesting property of exponential and natural log. If we have the natural log of 2, okay, and we take its exponent, so when we have the natural log of 2 and we take the exponent, the answer is going to be 2, right? So let us put that in place of 2. So we put e to the ln of 2 in place of 2. So then we are going to be having negative x plus 2 and e to the ln of 2, and we still have negative s plus 2 there. Well, I feel like I should not write this negative s plus 2 here, because it looks like it is affecting, the natural log is affecting it, but I'll write it correctly in the next line. So, and this is equal to negative 2. So this is the point where the Lambert W function applies. This is where you introduce it. So, oh, excuse me. No, we still have one more thing to do, and that is, let us introduce natural log to both sides, so that what we have there will be having natural log as well. So we have let me write it properly this time, so that we have negative x plus 2 multiplied by ln of 2, right? When we multiply the left hand side by ln of 2, so we have e to the ln, let me put down negative s plus 2 first, then before the ln of 2, and that's equal to negative 2 ln of 2. Okay, so this is the point where we introduce the Lambert W function. So the Lambert W function is a property of ln, the natural log and exponential function. So if you have, say, x multiplied by e to the x, so the Lambert W function for that is going to be x. So this lesson is not actually for that. So let us leave that for another lesson. So let's just take the advantage and make use of that knowledge now. So when you study the structure here, you will notice you just need to introduce now the Lambert W function to both sides, and you're going to be having this form. So you will notice what we have in place of s there now is negative x plus 2 and multiplied by ln of 2. So on the left hand side, and all of that is equal to Lambert W function of negative 2 ln of 2. So to find x now, our problem is reduced. We simply need to divide both sides by ln of 2. And we have negative x plus 2 equals Lambert W function of negative 2 ln of 2 divided by ln of 2. We then subtract 2 from both sides. We have negative x equals Lambert W function of negative 2 ln of 2 divided by ln of 2 and minus 2. So we get rid of the negative there, and we have negative Lambert W function of negative 2 ln of 2 divided by ln of 2 and plus 2. And that's how to solve that. Well, there will be lesson on Lambert W function in the next video. Please hit the like button and see you in the next one.